based on chemical equilibrium. So what is chemical equilibrium is, firstly we should understand what is an equilibrium. Okay, it is quite interesting thing to become a study. So put down the heading, the chemical equilibrium. Chemical equilibrium. Chemical equilibrium. Okay, chemical equilibrium. So what is chemical equilibrium is, firstly you should understand what is equilibrium. What is equilibrium? What is equilibrium? In early ages of your life, you have played a shisha game. We have played a shisha game where heavier person is sitting on one side and lighter person is sitting on other side. So this shisha will bend towards the heavier person. Okay, the shisha will bend towards the heavier person and lighter person will lift up on the upward direction. So what will, this is not balanced. This is not balanced. This is not balanced. Okay. Now if two equal weights persons are sitting on the both the sides, if two equal weights person are sitting on the both the sides, then this will be in the equilibrium. This will be in the equilibrium. So this is an example of physical equilibrium. This is an example of physical equilibrium. Fine. This is an example of physical equilibrium. So what happens is, here what things is going to balance it? Here the torque acting, here the torque acting, torque of both the sides, torque on both the sides will become equal, so that this will in the equilibrium. This will come out to be in the equilibrium. Clear? It is clear now. In both the sides, your chemical equilibrium is achieved because your torque is equal on both the sides. Fine. So this is an equilibrium. So for an equilibrium, what we have to study? Types of reaction. Chemical equilibrium. For chemical equilibrium, okay, for chemical equilibrium, what we have to study? The reaction is of two types. For chemical equilibrium, first type of reaction is irreversible reaction. First type of reaction is irreversible reaction. Irreversible reaction. And second one is irreversible reaction. Second one is reversible reaction. So irreversible reaction do not have any use in this topic because we have to consider only the reversible reaction. We have to consider only the reversible reaction in that case. We have to consider only the reversible reaction. So reversible reaction is what kind of reaction? This will move in both the direction. Okay, like suppose A to B is formed. So A to B is formed, then A is reactant and B is product. And B is product. The above direction is called forward direction. The above direction is called forward direction and below direction is called backward direction. Fine. Backward direction. So reactant forms the products. Clear? In every reaction, reactant form the product, but this is a special type of reaction in which a forward reaction is occurring and the backward reaction is occurring. Fine. So at chemical equilibrium, what happens is, at chemical equilibrium, rate of forward reaction is equal to backward reaction. Rate of forward reaction is equal to rate of backward reaction. Rate of backward reaction. Rate of forward reaction is equal to rate of backward reaction. Clear? So what is happening is RF is equal to RB. RF is equal to RB. This is the main thing. What is happening over here? Rate of forward reaction is equal to rate of backward reaction. Forward reaction rate is equal to rate of backward reaction. So in that case, there is a establishment of chemical equilibrium. Clear? So what is the rate? What is the rate? How it is being going to identified? Rate is basically concentration upon time. Rate is basically concentration upon time. Okay? Concentration upon time. Concentration upon time. Change in concentration upon time, if we write, then that will be a better option. Change in concentration upon time. That will be a rate of reactant, rate of reaction. That is change in concentration upon time. Rate of reaction. So reactant's concentration will decrease by the time and the product concentration will increase by the time. So decrease in concentration of reactant by time and increase in concentration of product by the time. That will give you the rate of the reaction. Fine. So we have to understand that this by a law that is given by the Goldberg and Waage. Okay. That is given by Goldberg and Waage, and that is called law of mass action. Let us see what is that law and clarify the things. So that is law of mass action. Law of mass action. Law of mass action that is given by scientist named Goldberg and Waage, something 1800 and something year. Goldberg and Waage was the scientist name in 1800 and something 87 or something like that, but we are not interested in that one. So what happens is, if a reversible reaction occurs, the rate of reaction, forward reaction, is directly proportional to concentration or active mass of the reactant. If the reaction occurring, reversible reaction is occurring, the rate of forward reaction is directly proportional to active mass of reactant's concentration, and rate of backward reaction is directly proportional to concentration of product's concentration. That is only the Goldberg and Waage law of mass action. Okay, so suppose that A is changing to B, there is a simple reaction. So rate of forward reaction is proportional to a concentration of A. So if we remove the sign, then there will be an introduction of a constant, that is Kf into A. Rb is proportional to concentration of B, and if we remove the proportionality sign, then Rb will become equal to Kb into B. Kf is rate constant for forward reaction. Kf rate constant for forward reaction. Rate constant for forward reaction. Forward reaction. Forward reaction. And Kb is rate constant for backward reaction. Kb is rate constant for backward reaction. Rate constant for backward reaction. Okay. That is Kf and Kb. Rate constant for backward reaction. Clear? That is clear to you? Rate constant for forward reaction. Now, at equilibrium, what happened? At chemical equilibrium point, what happened is, Rf is equal to Rb. Okay, clear? Rf is equal to Rb. So Kf into concentration of A is equal to Kb into concentration of B. Clear is that one is clear? Simply we have substituted the value. Suppose that this is the equation 1 and this is the equation 2. So Rf is equal to Rb means Kf into concentration of A is equal to Kb into concentration of B. Okay, that is the rate equation. That is the rate equation according to the Goldberg and Waage. Now what happens is, Kf at chemical equilibrium, Kf Rf is equal to Rb. Chemical equilibrium, what happens is Rf is equal to Rb. So Kf into concentration of A is equal to Kb into concentration of B. So what will happen? Kf upon Kb is equal to concentration of B upon concentration of A. So Kf is a constant, students, and Kb is also a constant. So if we will divide the constant from constant, we will get another constant that is called equilibrium constant. Okay, that will call equilibrium constant, that is Kc. Okay, so that is the main point. So this is equal to Kc is equal to concentration of B upon concentration of A, and that is equal to product concentration upon reactant concentration. This is the expression for Kc, chemical equilibrium constant Kc. This is the expression. This is the expression for Kc. Okay, so product concentration upon reactant concentration will be the equilibrium constant Kc. Okay, so by directly viewing the reaction, we will write the expression for Kc. We will not require proof of that one. And again and again, I am saying you have to put directly the equation of Kc by viewing the equation. Fine. So if suppose you have a equation, suppose that A changing to B, so Kc is equal to B upon A. And if suppose there is a concentration, C is changing to D, there is an equation, in that case C is changing to D, so we can write directly Kc, that is equal to concentration of D upon concentration of C. This is the Kc expression. And if there are more than one reactants, like A plus B gives C plus D, so what will happen? Kc is equal to concentration of C into concentration of D upon concentration of A into concentration of B. Clear? That is clear to you already? So Kc is equal to this one. If suppose there are 2a plus 3b, generalized equation, 4c plus 5d. Okay, there are multiplication of certain moles to the reactants and products. Fine. So in that case, what will be Kc? Kc is equal to c to the power 4 into d to the power 5 upon a to the power 2 into b to the power 3. Every multiplier will goes on to the power. Multiplier will goes on to the power. Clear? That must be clear to you. Understandable? Kc will be c ki power 4, d ki power 5 upon a ki power 2, b ki power 3. Okay. So if suppose that you have a reaction N2 plus 3H2 gives you 2NH3. All are in the gaseous phase. That must be required. Physical state must be mentioned properly. And if all the things are in the gaseous phase, what will happen? Kc is equal to NH3 square. NH3 square upon N2 into H2 N2 into H2 everything will be going in the power. So by directly viewing the reaction, we will write the expression for Kc. If suppose that PCl5 is going to change into PCl3 plus Cl2, all are in the gaseous phase. All are in the gaseous phase. So we have to mention the Kc value, that is equal to PCl3 concentration into Cl2 concentration upon concentration of PCl5. That will be always product concentration upon reactant concentration, students. That will be always product concentration upon reactant concentration. In that case, you do not have to compromise and always have to put the product concentration upon reactant concentration. So in today's class, we have seen how to write the Kc expression and how to find the Kc expression and how to write the Kc equation. So that will always be product upon reactant. So thank you very much, students. Have a nice day. And we will explain more thing about Kp and other factors which will affecting the Kc value in the next class. Thank you very much.